After understanding the stoichiometric calculations involved in any chemical reaction, the next thing to understand is the limiting reagent. See, whatever the problems which has been discussed in these stoichiometric calculations, we have usually are given in the numericals only one of the reactants, the amount of one of the reactants, and with respect to which the product is actually asked. Or if the product is given, the question is asking about the amount of the one of the reactants. Never both of the reactants amount is given. If suppose both of the reactants amount are given, then definitely they should combine in the simplest ratio, whatever is given as per the stoichiometry or the balance equation. If any one of those reactant is less than the required amount, that reactant will get consumed first completely and therefore will not allow the reaction to get completed. Simultaneously, the other product will become in excess or an extra amount, and that extra amount always gets left out in the reaction mixture, which gets mixed up with the product, and therefore it decreases the yield of the or percentage purity of the product obtained. So the reactant which is actually present in the less amount, whatever is required as per the stoichiometry, is called the limiting reagent. This limiting reagent causes two problems. First, it stops the reaction before it gets completed because it's not present in the required amount. And second, the other reactant, since it becomes now is present in more in amount, gets mixed up with the product, decreases the percentage purity and the yield of the reaction. So these are the two basic harmful things we have associated with this term. So in order to understand that how much of the reactants are to be taken, we must realize the importance of the limiting reagent, because ultimately whenever we will be doing this processes industrially, we must know that these reactants should be mixed in exactly the same proportion as what is given in the stoichiometric relationships from the balanced equation. Let us understand this from a numerical. It says 56 grams of nitrogen is reacted with 10 grams of hydrogen. Find the limiting reagent, mass of ammonia obtained, and the mass of other reactant left unreacted. So these are the three things we have to find out. The first is the limiting reagent we have to find out, identify it, find the ammonia obtained, and then find the other reactant left unreacted. Three things. Now let us write down the reaction first. Nitrogen gas reacts with hydrogen gas to give ammonia as a gas. Now, what is important to notice, we are given, this is the balance equation, we are given 56 grams of nitrogen and 10 grams of hydrogen. Now you can see both these reactants are given. Earlier, in the earlier numericals, we were given only one of the reactants and we were supposed to find out how much of the product is formed. And in those cases, we always used to take the other reactant in excess because we were never bothered about that how much of that is going to be there, because we were knowing since it is the other reactant present in the less amount as always gets consumed first. Now in this, since both of these are given, we have to find out stoichiometrically that which is present in the lesser amount and which is present in excess. Now how to find it out? Let us see this. See, we are given 56 grams of this, so moles of nitrogen are 56 and gram molecular mass or molar mass of nitrogen is 14 and 14 makes it 28. So it is 2 moles. So we are given 2 moles of nitrogen. Now, moles of hydrogen are 10 upon 2 because 2 is its molar mass. So that makes it 5 mole. So we are given 2 moles of this, 5 moles of this. But as per stoichiometry, you can see here 1 mole of this needs 3 moles of this. So 2 will need 6. So which is present in less amount? It is the hydrogen which is present in less amount. Let us see this. Since we know 1 mole of nitrogen needs 3 moles of hydrogen. Therefore, 2 moles of nitrogen will need 3 by 2 into 2. So it will be 6 moles. But we are given 5 moles. So which is your limiting reagent? Your limiting reagent is, therefore, limiting reagent is hydrogen. That's most important. Now, we will always find out product with respect to the limiting reagent because that is the one which stops the reaction before it gets completed. Never ever calculate the product with respect to the reactant which is present in excess. Because you always remember, since it's present in excess, more of the amount is there. Something of this will be always left out as unreacted substance. And if we have calculated the product with respect to this one, always the calculation will be wrong. So product is always calculated with respect to the limiting reagent. So how much of ammonia is obtained? We will calculate it from the hydrogen. Now, how much of ammonia we have to find out? Say 3 moles of hydrogen gives 2 moles of ammonia. So therefore, 5 moles will give 2 by 3 into 5. It's 10 by 3 moles of ammonia. So therefore, mass of ammonia is 10 by 3 into 17, which will be 170 by 3, approximately 56.6 grams. So this much is the mass of the ammonia produced in this case. Now let us find out how much of the nitrogen, which was the reactant present in excess, is left out in the reaction mixture. Now after finding out the amount of the ammonia obtained, let us find out how much of nitrogen remains unreacted. See, in the numerical, nitrogen combining with hydrogen to give you ammonia. This is 3, this is 2. We were given 56 grams of this, which when divided by 28 comes out to be 2 moles. And we were given 10 grams of this, which when divided by 2 comes out to be 5 moles. So this was our limiting reagent. Now we have to find out how much of the nitrogen remains unreacted. See, in unitary method we know the substance whose amount is to be calculated, it's always kept on the right hand side. So we will use the same information here. We know 3 moles of hydrogen combines with 1 mole of nitrogen. Therefore, 5 moles will combine with 1 by 3 into 5, because we are given not 3 moles, we are given 5 moles. So, you can find out it will come out to be approximately 1.67 moles. Now 1.67 moles, it means therefore moles of nitrogen consumed will be 1.67 moles. Therefore, moles of nitrogen left will be 2 minus 1.67 moles. So it will be approximately 0.33 moles. This much is left out, unreacted. So the mass of nitrogen unreacted will be 0.33 into 28, which will be 1 by 3 into 28, 9.33 grams. So this much remains unreacted out of the 56 grams, and the rest combines, the whole of the hydrogen combines, rest of the nitrogen combines to give you the balance amount of the ammonia.